Good morning. Oh, hey, that's pretty hot. Cool. Okay, this is good because I often don't project enough. So, welcome to Java Code 1. So I guess this is one of the pretty much the first main session, right? It's good. All right. Is everybody ready? Ready for an exciting week? Okay. I'm just curious, how many people have been to Java 1 before? All right, so there's a few Code 1 newbies. Okay. All right, well, this session is not really about Java, but I will take into account your experience with Java in this talk. So what I'll be talking about is front-end web development. Basically, this talk is for people who have been working with Java for many years, mostly on the back end, or maybe some Java web framework technologies like, Grails or JSF or something else, one of the many ones that have been around over the years. But now there's all these new cool front-end tools and frameworks using JavaScript and all this TypeScript and all these different tools and things like that. And so the goal of this talk is to basically sort of give you an idea about the landscape. Okay, so I'll start by just telling you a little bit about myself. My computer. All right. So my name's Kito. I run a little consulting company called Virtua, where we do training, consulting, mentoring, architecture, etc., around Java EE technologies, but also front-end technologies like Angular and web components as well. So I've been working pretty much when I started my professional career. That was sort of when Java first was gaining traction. So I've pretty much been working with it my entire career, but I've had the trajectory of working and building applications in lots of different environments over the years, from working purely with Java, working with Java web frameworks like JSF, working with Java EE, and then going to building front-end web applications that are purely browser-based using web components in Angular and JavaScript. So I've kind of followed this path, so I have a good understanding about the similarities and the differences between the two different ecosystems. Okay, and that's what I'd like to help you with. My company is also a partner with another company that develops open source UI toolkits called PrimeTech. So they have some tools for Java server faces called Prime Faces, and also some tools for components for Angular and React as well. So I work with them. I ran a website a long time ago called JSF Central. It's still up. Hasn't been updated in a while, but it's there. I host a newscast called Enterprise Java Newscast. We haven't come out with a new episode for a while. I'm hoping to kick it off again at some point in the future. I'm a Java champion. I'm also a Google developer expert in web technologies. And I've spoken at lots of conferences. So that's my story. So before I begin, I want to get a handle from the audience. How many of you consider yourselves like core Java developers? That's your sort of main thing. Okay, how many of you consider yourselves like a JavaScript developer? Okay. How many of you have never written any JavaScript? Okay. How many of you have just written a little bit of JavaScript where you throw it in some page and maybe a little bit of jQuery or something like that? Okay. And how many of you like JavaScript as a language? Very curious. Okay, interesting. All right. All right, so I'm basically, I've done this session between like 45 minutes and like 60 minutes or 70, and so I'm going to go through lots of things. I'm going to throw lots of things at you, because we only have 45 minutes and now we have about 41 minutes. But at the end of the talk, you'll at least have some idea about what some of these technologies are and how they relate to the tools you're used to, okay? So we're going to start with a few vocabulary words. We'll then look at JavaScript. We'll look at tooling, web frameworks, and the web platform as a whole. And when you're done, you'll be a full stack developer, right? Woohoo! So, a few terms, and these aren't necessarily the most important terms, but they're just terms you run across, and you're like, what the hell is that? So, one of the ones I came across was monkey patch, and I'm like, what is a monkey patch? That sounds really weird. And basically, it's a way to just basically patch dynamically a feature of a particular library or something like that, okay? And this is more popular in dynamic languages because it's much easier to do that than in a static language like Java, okay? So you'll actually find something which is called a monkey patch for XYZ library, right? So just a way to extend or enhance the behavior of an existing library. Another one is a shim, okay? And a shim is basically a way to add support for an API in an environment that doesn't support the API, okay? And often you'll see this used in terms of browser support, right? So there'll be like some browser feature that browser like IE11, for example, doesn't support, and you want to provide support, and there will be a shim that will provide that support, okay? Usually a shim is fairly small. It's not like a huge thing. But it's basically saying, OK, I want to provide this feature on this platform. It's a standard, or it's something that should be there, but it's not there yet, so let me just add that functionality. Okay? This is another thing that's easier to do with dynamic languages and dynamic platforms. Right? You can just add functionality to an existing object. So for example, let's say there was a good example of this, I ran into this recently. There's a file list object, which is part of the browser API, right? And IE11 does not support a couple methods on it, like I think push and slice, okay? So I haven't looked at it, but I'm assuming there is a shim or a polyfill, which I'll talk about in a minute, which will add those two features to that API, to the file list object, okay? And that's something that's harder to do in a statically typed language, but in a dynamic platform, you can actually add methods and properties to existing objects, okay? And that's something you can do with the shim, okay? So another example is a polyfill, which is usually a bigger thing, but it's the same idea. It's the same idea of providing functionality for a feature which doesn't quite yet exist. And polyfills are usually used in conjunction with the web browser. So a common example would be, there's some great new feature that's part of the HTML spec, but it's not yet available in that particular browser. You can have a polyfill which can implement that feature. And this is very common with a lot of the new HTML5 features, some of which we might get to at the end. Basically the idea is that there's whatever API that's been defined, right? And when you go to whatever web page, you just download some extra JavaScript, which is a polyfill, that adds support for that feature. And it could be as simple as properties being added to objects, but also it can be much more complicated features. And again, this is possible because the browser and any sort of JavaScript execution environment is dynamic, right? So you can actually download code which can actually change the behavior of the underlying platform, okay? Which is good and bad. But that's basically what a polyfill is, okay? So if you come across some feature that you need to support, it's available in some browsers but not others, there's usually a polyfill that will provide that feature for you. And of course, there is additional overhead involved, but in a lot of cases, the polyfills are made very performant, okay? So middleware is one which threw me for a loop, because I'd see people saying, hey, I have this middleware to do X, Y, Z, and I'm like, middleware is like this back-end thing, it's like this is middleware, it's like servers, and I'm like, what are you talking about? And it turns out middleware actually came from the Express router, which runs on node.js. And essentially, it's just a function that takes a request object and returns a response object. So basically, it's sort of like a servlet filter, essentially. You can think of it that way. But it's not always used in that context, but basically, it's a way to intercept a call, okay? So if you ever see middleware, think of it as an interceptor or servlet filter or something like that, depending on the context. So another one is a transpiler. How many people have heard of a transpiler before? Okay, so a decent number of you. So a transpiler is a source-to-source compiler. Okay, so basically it'll take one language and spit out another language. Okay, And this is very popular in the JavaScript world because JavaScript has not always been that great of a language, right? It was written very quickly and then sort of became very popular because it was available in the browser, right? But until recently, it didn't have that many great features. So if you wanted to have some more features, you could write in a different language and then turn it into JavaScript because JavaScript always runs everywhere in the browser, right? So regardless of which language you like, if you want to actually run it in the web browser, you kind of has to turn into JavaScript at some point. Okay, so a transpiler doesn't have to turn a language into JavaScript, but that's the use case we're talking about here, is basically turning some other language into JavaScript which can run in the browser. Okay. All right, so I'm not going to spend too much time on this. I just want to talk about a few JavaScript features. So I know in the Java community, JavaScript has a bad rap, right? It's this weird dynamic language, and there's all these funky edge cases, and it can't really do much. And what I just wanted to show was that even though all those things are still true, because, well, you know, like most languages, you have legacy stuff, right? So just like Java, until very recently when they started pruning some things, right? All the old APIs and features are still there, right? So JavaScript still works like you're thinking, but it has a lot of great new features, okay? Very, very modern features. So, so just from a historical perspective, it really was written in like 10 days by this guy, Brandon Ike, who actually I think until recently, or he may still be working at the Mozilla Foundation now, in 1995. Okay, so it's been a long time, right? And basically, it got standardized. It was written by him at Netscape. How many people remember Netscape? Okay, good. I'm not the only little person. All right. So it was standardized as ECMAScript, and then there were a few versions released, right? But you'll notice the difference between ECMAScript 3 and 5, right? 10 years. And this is, you could consider this sort of a casualty of the browser wars, right? Where IE and Netscape were fighting and things like that. And it really wasn't in Microsoft's interest to advance JavaScript. And it sort of stagnated. And this, to me, is the reason why it has the reputation it has, because for 10 years it sat there and didn't evolve, and people just added lots of libraries on top of it to try and make it do stuff, right? But version 5 came out in 2009, and that added a few nice features like properties, getters, and setters that we still don't have in Java, right? And things like that. But now it's moving very quickly. So there's ES6, which came out in 2015. There's ES7, ES8, and they're constantly working on new versions. Okay, and these new versions have very, very modern features. Okay. So one of the things I also wanted to mention is that Java, just like Java, JavaScript has to have an execution engine, right? Because it's it's a dynamic language, but it also has to have an underlying engine to run it on whatever platform. So the same way that Java is really great at running on different platforms, just remember JavaScript really is as well, because you use web browsers on different platforms, right? On iOS, on Android, on Windows, on Linux, on Mac OS X, or Mac OS now. So regardless of what platform you are, there's some JavaScript execution engine, okay? Which is just like a JVM, but except it runs JavaScript. So there's a few implementations in Java, actually. Rhino comes with JDK 6, and in JDK 7 Plus, there's Nashorn, okay? These will run JavaScript on the server side for you. So remember, even though I'm talking a lot about browser stuff, JavaScript runs on the server just as well as it runs in the browser, okay? So Nashorn ships with the JDK, but it's not quite as up to date as the other JavaScript engines out there. So the most popular one is probably V8, which is the one that runs inside of Chrome, okay? There's also Chakra, which is the one that runs inside of Edge. There's also SpiderMonkey, which is what Firefox uses. And there's Nitro, which is what Safari uses, okay? So even though there's the browser, these are all actually the execution engines that run JavaScript, okay? And in some cases, they can actually be removed from the browser. So Chakra is usually what's used for Node.js, which runs on the server, okay? You can also run Node.js on Windows using Edge, using Chakra, the Microsoft engine as well. Okay, so even though like usually the engine is tied to the browser, it doesn't have to be. Okay, and if you're really curious, just like everything else, there's a whole bunch of other ones. So you can always check out Wikipedia to get a full list. So I've mentioned Node a couple times. So we know that browsers run JavaScript, right? Node is usually the server-side JavaScript engine. It's basically just a standard JavaScript engine plus some libraries and a package manager called NPM, Node Package Manager, which I'll talk about in a minute. Okay. So it is entirely possible, and a lot of people do this. They'll write the front end and back end all in JavaScript because you can write the back end in JavaScript as well. Okay. And also, if you were to use the Nashorn engine, you could actually write JavaScript which interface with Java libraries if you wanted to. All right, so ES6 is pretty much the modern version of JavaScript, like the first really modern version. There's other ones, 7, 8, 9. But most JavaScript engines support some of the ES6 features. Nashorn has a few of them. But not a lot of them. And these are a few of the features. I'll just talk about these very quickly. I'll make sure the slides are available if you want to look at these in more detail. But the first one is that you can actually use a class syntax in JavaScript now. So JavaScript has always had this sort of prototypical object model and prototypical inheritance, which has been sort of hard to wrap your head around, especially coming from a Java/C++, C# background. Okay, so with ES6, you can actually write something that looks pretty much like a class in any other object-oriented language, right? So you basically can have a class, you can extend, etc. So that's one of the new things. There's also let and const. So how many people have seen var used in JavaScript? I'm assuming many of you have. Okay. So usually when you define a variable, you say var xyz. The problem is that it used to do this thing called variable hoisting, where essentially no matter where you declare var, no matter which block you're in, it would basically move it up to the top of the enclosing function. So you had all these weird cases. So let basically just declares a variable like you're used to inside of whatever scope you're in, okay? And const does the same thing, but it is pretty much the same as a final variable in Java. It's one that you cannot mutate, okay? So in any modern JavaScript code, you'll find let and const being used. There's also an arrow function, which, is pretty much like a lambda expression. Okay, but JavaScript has always had the ability to pass around functions, so that's not really a big deal for JavaScript. The only real change for the arrow function versus a normal function in JavaScript is that it preserves the use of the keyword this. So one of the annoying things about JavaScript was before, if you passed around a function and you called this dot whatever, it would remember, it would be this of the whatever was calling that method, that function, not of where you would expect it to be, which is basically in the calling, the code that declared it, okay? So using the arrow function preserves this so it's logical and saves a lot of pain, okay? There's also promises as well. And a promise is pretty much like a completable future in Java. How many people have used that in Java? Okay, so a few of you. So basically, it just lets you create some code that can respond to something later. So it's basically a way to do asynchronous programming. So in this example, this function returns this promise, right? And basically, it's going to wait some period of time, and then after that, it's going to end. It's going to basically resolve itself and send a message, okay? So this is an example of using that particular promise. Okay, so this is basically saying, it's actually 2 levels deep too. It's saying wait 100 milliseconds and then display this message. Okay, and then it's calling itself again to wait 200 milliseconds and display this message as well. So basically, promise is just a way to say, okay, do this work whenever you're done with whatever you need to do. Okay, which is a handy way to do asynchronous programming. Symbols is another one which I like a lot, and I don't really know of another language equivalent to symbols, but basically they're a way to define sort of a constant. It is essentially a global constant that it doesn't matter like what the name of it is. It's basically an object reference. Okay. So here I'm saying this is one symbol, this is another symbol, but they're not equal to each other. Okay. And that you can never have 2 symbols that are equal to each other, pretty much. Okay. So even though they have the same name, they're not going to be equal to each other. Now you can of course declare a new variable that's equal to a symbol, right? But you can't create a new symbol which is going to be equal to another existing symbol. So it's basically a unique object reference. Okay. So I think this is a great way to handle constants, and it's also used internally in some JavaScript classes to keep track of property names and things like that. So it's kind of a neat feature. Another feature is template literals. So here you can actually, just like you would in any sort of template language, you can declare a string, but inside of the string you can reference variables. Okay, so it's a much nicer way to do things than string concatenation or even printf style display of strings. And in some JavaScript frameworks, this is actually used for constructing entire templates with HTML and everything else. Destructuring is another neat one. So destructuring basically allows you to take properties out of an existing object and put them in variables. Okay. So a very common case is you have an object with like 20 properties and you want to put 3 or 4 of them in different variables to work with. Okay. So here, let's say get AST node has 20 properties, but you want these 3, and this basically assumes that those properties have these names: op, LHS, RHS, etc. Okay. So this line right here is the same as this line down here. Okay. So basically, it's a shorthand, saves you a little bit of time for declaring variables. Okay. All right, so there's lots of other features. There's also module support, which is sort of like Java modules, but also a little bit different. But it's the same idea that you can have basically a namespace for your code. It's not quite as, usually it's more granular than Java modules, so you might have, a module might only have a few classes in it, whereas in Java it's more like a module is a collection of different packages and things like that. But it's basically a way to organize your code and provide namespaces so you avoid name collisions. There's also generators and iterators, which are useful for iteration and things like that. There's also maps and sets, which is something I've been missing in JavaScript for quite a while. And even they even have things like weak maps and things like that, like we're used to in Java. They also have proxying and reflection, which are newer features as well. These are things we're also used to in Java. And there's also much better support for standardized internationalization and localization as well. All right, so that's your quick JavaScript update. Just scratches the surface, but should give you an idea. I want to talk for a minute about transpilers. So transpilers are great for a couple things. One of the key things is not necessarily turning, one language into another, but just basically providing access to new features. So a lot of the newer JavaScript features are actually syntactic sugar that can be implemented using older versions of JavaScript. So let's say you're working with a browser like IE11 that supports an older version of JavaScript, but you want to use some cool features without a whole bunch of polyfills and things like that. You can use a transpiler, which will basically allow you to use all the cool new features and run them in an older version of JavaScript. Okay, so there's a few of these. Tracer is one of them. Babel is probably the most popular one. and TypeScript as well can be used for that. So all of these allow you to use newer JavaScript features with older versions of the JavaScript execution engine. Okay. Now, there also are transpilers that give you additional language features. So one of the things that JavaScript, like many dynamic languages, doesn't really have is type safety. Okay. So if you want to add type safety to your JavaScript development, Flow is one option. My favorite is TypeScript, which is from Microsoft, actually. And what they can do is basically give you extra language features that remind you more of type-safe, statically typed languages. Okay. So TypeScript, which is heavily used in Angular and also in other projects as well, lets you write code that looks a lot like Java or C#, right? So I can have an interface. I can even have generics, okay? And here I have a class which extends another class using generics. I can also do cool things like define these types, so I can say, whatever type this is can be a number or a string or whatever types I want. This is one of my favorite features. It's called the union type. Here I'm creating a new greeter, which is a string greeter, essentially. Okay, and you'll notice in my constructor, the type here is whatever I passed in, right? So that means the constructor is going to expect a string here. Okay. And then there's just some examples of using it. So this is really just scratches the surface, excuse me. But TypeScript has lots of additional features that are familiar and helpful for developers that are used to statically typed languages. Okay. And what's interesting is that at the end of the day, what happens is you run the TypeScript compiler, and it just spits out JavaScript in whatever version of JavaScript you want to support. Okay. So this is why we call it a transpiler. So at runtime, it's still running normal JavaScript code. It's just that it gives you additional compile time safety. Okay. All right, so that was the output of that. You can also use a transpiler to work with JavaScript in a completely different language. So one of them which was popular for a while is CoffeeScript. Has anyone heard of CoffeeScript? Okay, so a few of you. JSuite is one that I like. I think you should check out. It actually lets you transpile Java to JavaScript. It actually uses the TypeScript compiler in there as well, so you can support lots of existing JavaScript libraries. ClojureScript is another one for using Clojure. Kotlin can transpile to JavaScript, Scala, and a whole bunch more. So basically, you can take any language that you like and turn it into JavaScript. Really, the question is, what are you trying to do? And to do whatever frameworks or libraries that you want to use, support that. But it's certainly an option. OK, so now let's talk a little bit about tools. The first topic is package managers. So you'll see this term package manager in the JavaScript world. And you can think of it sort of as a dependency manager. OK? So the popular package managers are Bower, Node package manager, or NPM, and Yarn. Okay, and you can think of well, we'll talk about these in a minute. All right. So NPM. So basically, with NPM, it's a package manager, right? So its job is to keep track of dependencies. Okay. So it's sort of like working with Maven, but without the build part. It's sort of like working with Maven and just the dependency part, or working with Gradle and just the dependency part. Okay, just like Maven has Maven repositories and the global or the main Maven repository, and you can have your own Maven repositories. And most Java tools work with a Maven repository, even if you're not using Maven, like you're using Gradle or something else, right? NPM's kind of like that. There's the main NPM registry. You can also have your own internal NPM registries as well. Okay. The main difference is that usually a Maven repository will store binary artifacts, right? So whatever jar files you've created, it will store in the Maven repository. The NPM registry is really more about pointing you to a Git location. So it actually will point to GitHub or whatever other Git repository if you're using it internally. And that means that there are some benefits because it's obviously probably a lot easier to manage, right? But the drawback is that if like someone, kills that Git repository, then all of a sudden your dependencies get screwed up. So it's a little bit different. Although I know that some of the dependency management systems that do Maven also will do NPM, so I imagine they have ways to handle that. So you can have your own local copy of artifacts as opposed to having to go out to GitHub to get something. Okay. So NPM uses a package.json file, which is sort of like a pom.xml file. Okay. You'll find in the JavaScript world, everything is a JSON file for the most part, not an XML file. XML is not cool. So there's npmjs.org, which is sort of like search.maven.org. And there's an NPM incorporated company, which sells the service and support for NPM, a lot like Sonatype, which does it for Maven. So this is an NPM package.json file, okay? And you have your name, your version, license if you want. These are little scripts that you can run for your project, which is handy. You can just do npm run and then the name of the script that you want to run. But the important thing is this. So these are all the dependencies, okay? So you specify a dependency, use this symversion syntax, which specifies how far, whether you want to specify a minor or major version update, whether you want to support that as well. Okay, you can do that in Maven, but it's a little more. This is actually a little more fluid, which is good and bad. So you specify all your dependencies. Okay, you can also specify ones which are only for development, so they won't be deployed. And that's pretty much it. There's not a whole lot more to this. And basically, all these are going to be looked up in the NPM registry that you're using, either a global one or a local one for your organization. Okay. All right, so there's also CSS preprocessors. So CSS is, of course, a big part of web applications, right? And just like anything else, there's always more features we want than what's currently supported by the platform. So a CSS preprocessor will take CSS and then turn it in, give you an enhanced language to use for CSS, and then turn it into regular CSS that the browser can use. So you can have features like variables, imports, mix-ins, inheritance, operators, functions, all sorts of cool programming constructs. And the most popular one of these is Sass, another one is Less, and there's also another one called Stylus as well. So if you see that, it's a CSS transpiler preprocessor, okay? And they look a little bit like this. You see there's actually variables, you can do imports. You see I'm using all these different variables here, okay? And there's a lot more things you can do too. You can have little functions, like here's a function as well, okay? So Sass and other CSS transpilers really let you sort of take CSS to the next level in terms of management, okay? All right, so build tools. Well, the first question you might ask is, well, what is there to build? I just have a whole bunch of JavaScript files, right? And images and style sheets. What do I have to build? Well, it turns out with actual larger JavaScript applications, there's a lot of stuff, right? There's JavaScript, there's Sass, there's JPEG, CSS, etc., right? There's also dependencies between them. So a build tool will basically take all of your artifacts and then output a bundle, or at least a set of files, which can be statically deployed on a web server. It doesn't have to be a fancy Java app server. It could just be Apache or any sort of standard web server, okay? And especially if you have a transpiler or a CSS preprocessor, you're going to have a build step involved, okay? So that's what the build tools do. There's a few popular ones, grunt, gulp. So if you see these names, these are build tools. Webpack is another one, okay? Browserify and Brunch are ones as well, okay? So these are all essentially build tools, okay? Now, of course, they're very different. So grunt is sort of like, it's basically sort of like Ant, except it uses JavaScript, okay? So you define tasks, okay, and each task has certain properties that you can set. At the end of the day, if you go down here, you register a task, and that task is defined of other tasks. So the default task calls JSHint, QUnit, clean, concatenate, and uglify. Uglify basically shrinks a file and basically takes all your variables and gives them boring names that don't make any sense and have like one character so that it's a smaller file. Okay. So grunt is sort of like ant. I think of it as sort of the same thing. And a lot of these aren't as popular anymore, but you will see them somewhere. Okay. Gulp is another one, and I like gulp better. It's basically lets you define tasks in the same way, but it does it using streams. So you basically get a stream of data and you pipe it along sort of a pipeline. So you can then transform the data, okay? And you can also do stuff asynchronously, which you can't do in gulp. So if you want a lot of control over your build, gulp is usually a better choice, okay? All right, and then there's webpack. And webpack is sort of a module bundler. It basically will take a module and then bundle things together and then try and create a package which can be deployed, okay? The thing is, anything can really be a module. So a module can be a CSS file, or it could be a JavaScript file, or a TypeScript file, or something else, okay? And it reminds me much more of Maven because you don't really specify what's going on. You just provide some information and then magically it does stuff, okay? So this is a webpack configuration file. So we're adding a plugin, right? And then we're using some configuration. We specify the modules, some rules for the modules and the plugins, and then that's it. So you don't really know what it's doing. You just provide information, and then magically it'll spit out a bundle for you, okay? Now, when I say you don't know what it's doing, what I mean is that it's not as granular as like gulp or grunt, where you say explicitly exactly what to do, okay? And you'll find that different web frameworks will build on top of these things. So for example, Angular uses webpack internally to do a lot of its magic, okay? Another tool that you may see is called Yeoman, and it's a cute little scaffolding tool. So basically, it's used as a way to generate a starter app. So let's say you want to use a new web framework like Angular or Vue. Angular is probably not a good choice because they have their own tooling, but let's say you want to play with Vue or Aria or React or Polymer or something. You can get a human template that'll just basically generate scaffolding for your project. So just a way to start out the project that you're kind of trying to work with, okay? It's sort of like Maven archetypes, essentially. All right, so I'll give you the 5-minute tour of web frameworks. So the first thing is forget about jQuery. It was cool a long time ago, not anymore. And you'll find actually if you try to use any other web framework, they'll probably tell you not to use jQuery because it'll interfere with whatever it's trying to do, okay? And the other reason jQuery is not so cool anymore is that a lot of the features have been built into the platform now. So a lot of things like just finding an element in the page is all part of the standard web APIs, okay? So web frameworks now can do lots of different things. Basically, it's an entire application that talks to the backend. So I think of this, let me go up a bit. I think of it sort of as the return of client server a little bit. But the difference is the server is usually a REST backend, right? But the similarity is that all the code is running in the browser. Okay, just like with the client server app, all the code is running in your application. I mean, on your desktop machine. Okay. How many people here remember client server apps? I just don't know if I'm making sense to people. Okay, so only a few of you. All right. Well, client server app was like a Windows application that would talk directly to a database. So sort of a two-tier architecture, they would say. Okay. So web application frameworks usually have a single page architecture. So basically your whole application loads, and then it does internal routing between different views or pages. Okay. So usually when you go to a new page, it's not actually reloading the entire application. It's just basically changing what you see on the page. Okay. That's what we call routing. And also, a web framework will give you some component models, support for working with model objects, and a standard way to structure your applications. All the things you usually expect from a framework. You also have support for talking to the backend. Sometimes you'll have state management, things like handling views, things like that as well. Another thing in which you often will get are runtime or compile time optimizations. So Angular has done a lot of work with its own special compiler, which will get you, as time has gone on, has made the applications faster and faster, okay? React uses a virtual DOM, so it does a lot of DOM manipulations, but they're not direct manipulations on the DOM. It basically does all the manipulations on a virtual DOM and then publishes those to the actual DOM, okay? And when I say DOM, I'm talking about the document object model in the browser, okay? So the idea with a virtual DOM is that it's going to be faster than actually manipulating nodes in the real browser, okay? Okay. A lot of these tools also provide command line interfaces, and the command line tools are quite powerful. So usually if you're working with some web framework, there'll be some command line or CLI tool which you can use to create new projects and add new features and things like that. All right, so also you can have data binding. So on the top here is an example of Angular data binding. So you have a template, and you can just throw in a reference to the object. This is something which you've probably seen in any Java web framework as well, okay? Except the difference here is that this is all client-side. So the property hero in this example is a property of the actual component on the page, and it may have grabbed hero from the server, using REST API, but it's actually an object which is a property of the component in the web application, okay? And there's also one-way data binding, which means you just pass data in, and two-way data binding, where you pass data in, but also it can be updated by the component. And there are pros and cons to two-way data binding. Some people don't like it, some people like it. But a common concept now is to just pass data in, and then if you want data back out, you just respond to an event to get it back out. All right, so some of the web frameworks which have been around for a while are Backbone and Marionette, Ember, AngularJS, okay? AngularJS refers to AngularJS 1.x, okay? Angular without the JS at the end means 2.x or higher, okay? So if you see that terminology, you'll know the difference, and they're radically different. Angular 2 and higher is all TypeScript. It reminds me a lot more of Java. In terms of the way it's designed. It has dependency injection and all sorts of other features. AngularJS is older and pretty different, although it has a lot of the same concepts, okay? Okay, so other ones you'll see are React, Vue, Aurelia, and Polymer, okay? And I'm almost out of time. I knew this would happen. All right, one thing I'll point out is that any web framework these days is going to be component-oriented, which means you build your application out of components. And this makes a lot of sense for me because I come from a Java Server Faces background, where that's how we built applications with Java Server Faces, was using UI components. So all the modern frameworks are built that way. And Angular, this is just an architectural view. Angular, when you work with it, reminds you a lot of Java because it has dependency injection. You have components. JavaScript also has what they call decorators now, which are pretty much conceptually the same as annotations in Java. I didn't show an example of that, but Angular uses that very heavily. So you basically have a lot of decorators or annotations on things, and you have dependency injection and things like that. So it makes a lot of sense to an enterprise Java developer. React is a little different. It is focusing more on the view layer, okay? It's very functional in the way it works. It has this special language called JSX, which is sort of like JSP, where you can basically use it to provide templates for your components. And for more complicated applications, you need another piece to handle the state, okay? And usually that's something like Flux or Redux, and they handle sort of the global state of the application, things like that. This isn't really a framework, but I wanted to mention it as well, is Polymer. It's a library that provides additional features for web components. And web components are a really awesome HTML standard that lets you have reusable components that run in the browser. regardless of the framework you're in. So Polymer just provides some additional features on top of web components. So it's probably one of my favorites. There's also some third-party components for working with Polymer as well. Another thing which you'll see is managing state in web applications. So what happens is as your application gets larger, it's harder to keep track of all the different data, all the data in your application. And there are a couple patterns. There's a popular pattern for handling this called CQRS. And basically the idea there is that you put all your data in a global store, and then you dispatch actions that operate on that data. And then you have a way to select the data and get it back to your application. Okay? So it sort of separates out different parts of your application. And you'll see this used with Flux, Redux, and NGRX. So when you see these terms, think, oh, there's that CQRS thing. What was that? You know, it'll give you an idea. And you might end up with a picture like this in your head, where you have a UI component, you have this action, okay? You may have some middleware. Remember, this is just essentially an interceptor, right? And then you can have a reducer, which sort of mutates the data, okay? And then the views that you have are selecting different parts of the data. So it just gives you a way to sort of conceptually segregate the work that you're doing from the data you're doing. And some patterns, some frameworks like Redux actually require that your data is immutable as well. So, all right, looks like I'm actually out of time. Let's see. The only other point I'll make is that the web platform has matured a lot, okay? So while I've talked about all these different tools and frameworks, there's actually a lot you can do with the web platform as itself. Yeah, I'm not going to get into all of that. But just remember there's all these cool things like WebSockets, WebRTC, web storage, IndexedDB, Canvas, WebGL, Bluetooth support, USB support. All this stuff is actually built into the browser now in a lot of cases. So just remember, you know, as you have to work more with browser-based applications, there's a lot the platform can do as itself, all by itself. And a lot of what the frameworks do is just give you a way to work with that stuff. So you can even work with a lot of that stuff without a fancy framework, just by using the web platform itself. Okay? All right, so I think I'm out of time. If you have any questions, you can come up after. And I wish you success on your voyage into the world of front-end web development. Thank you.